Hello, good afternoon, Chairman of the session. My name is Musbala Abdullahi. I am here to present a title, Exploratory Involuntary Cognitive Cues Analysis for Lie and Truth Detection. This is an approach from real-life court trial videos. This is the presentation outlines. I have our introduction, exploratory analysis. Then we are also going to look deep into some kind of techniques of exploratory. Involuntary cues analysis and discussions. Then we are going to look into multivariate involuntary analysis. So introductions. This course title, it has to do with a biometric system design and development. So in figure 1, we are going to just give some highlights on the population of biometric market growth across the globe. We can see the indices, that is, we have around 42.9 USD billion, which is the CAGR, cumulative annual generated revenue by the biometric recognition market. Then there is also a CAGR of around 82.9 USD billion, which is the projection by 2027. So this is the projection of the last year, 2022, and where it is hopefully by this research that by 2027 the projection is going to hit into this 82.9 USD billion dollars. Then as well we can see the other regions and region. So this it is what makes this title a very is a active research area, and also that needs a very urgent intervention, because we have a lot of issues which we are going to snapshot some of it here, because in the previous researches and the development in the biometric recognition system, there are many yes, of course, there are many existing techniques that tries to develop a system that can be able to recognize and land some different kind of information, such as the continuous data and the static data and the rest of it. But in this work, we are interested in information that is captured by the computer vision technologies, which try to bring RGB, that is RGB video data set, which is a practical real data set which is obtained from the court trial and the police investigation interviews. So this data set is also further utilized by some other recognition method using machine learning and some emerging deep learning method for both lie recognition and the truth-telling detection. So, however, some intentional and unintentional actions, which we refer to as involuntary cognitive cues by the from what we have investigated on the existing literature. So this kind of unintentional and intentional actions, as known as involuntary cognitive cues, try to make it very difficult for the ML and DL method to detect whether the person is lying or is telling the truth during a testimony. So these are kind of involuntary actions are also obtained from hand, eyebrow, facial expression, body, and eye blink. So this information tried to pose a challenge in the existing recognition algorithm, because the majority of the method try to capture this information, but however, they lack multimodal involuntary cues fusion. And then as well, majority of the existing works lack the complementary information that leads to the recognition or detection of most of these responses by the during the interview and court trial sessions. And then also the existing works also lack some relationship, lacks to explore the relationship among the multimodal involuntary cues, which may have a significant influence to lie detection. So in this method, we try to develop our framework on the collaboratory environment, which is known as a collab, that is the framework developed by Google. So we also try to use some existing state-of-the-art Python packages. So these packages are developed by some different existing pipelines of the Python, such as the matplot, numpy, seaborn, scip, and the rest of it. So in this work, we also create what we call a README files, which it describe the kind of packages we utilize for this development. And as well, we also describe some highlights on some aspects on how we can run our codes. So the first figure here, it's try to describe the kind of the data set, which is in comma separated values format. So then we also now try to do some kind of pre-processing so that we can get rid of the outliers and some information. So the first thing we did is to try to do a data cloning. So in this data cloning, we try to use one function from the Google Club, which is known as a Google Club import. So we use this library to import to upload the files into the Google Club, and then as well we now ended up having 13,410 bytes of this information. So and as well we also extend the use of the packets IO, which is try to give us the ability, or it's a package that gives a capability of reading the .csv files into a data frame, so that we can now be able to use the pandas as it is shown here. So then the next one, we try to do what we call some dropping some missing and empty spaces, because there are a lot of empty spaces in the data set. So therefore we use a function drop NA so that we can drop those spaces and cells that are empty. So then after that, then we now do an index assignment. So in the index assignment, some are unknown. So because there are many some columns that are not well defined and have no index to so in order to have an easy access to all the data frames, so we now try to allocate some index so that we can be able to call the headlines or the headings of each cells in the column and rows. So then the next one, we try to also do some capitalization. We use a function string.capitalize, which is a function in the Python 3.0. So it enables us also to call the titles of each data frames using the first letter of the title to start with a capital letter. So this is some kind of pre-processing with it. So the next one, we also try to do what we call a correction of missing values. So we assume that there are some missing values in the data set. So we now use also a function in the Python, which is known as missing.na. So we use this isna as a function so that we can check and find out. So this is the result. Actually, in this data set, we don't have any missing values. So the next items in this framework, we also try to develop some features, because we have around 39 features. So out of these 39 features, most of them some are significant, some are less significant. This is what was the present challenge by some recognition algorithms. So we selected only 17 features, which it is described here. So out of these 17 features, we tried to develop some kind of function in this collab, so that we can see the relationship, how those two or more these values and the features have some kind of relationship. So we have just some snapshot of it. So then the next thing is to do the exploratory visualization of the data set. So we use the Seaborn as the package, where we have all the features. It's imported because we already have the data frame. So therefore, we use this function sns.boxplot, where we have a box plot of all the selected features, the 17 selected features. So these selected features are now clustered within the two classes, that is the deception and the truth telling actions. So therefore we have this, and as well we can see from this box plot, there are some kind of analysis. So in this kind of analysis, we have some percentile, that is we have the 25%, 50%, 75%, and 100%. So in a nutshell, because we don't have time to explain everything, I will just snapshot the bottom and the top of the box plot. At each box here, we have the top and bottom. So any future point that lies in outside outside the bottom of the box, or outside this line of the top of the box. So it means it is an outlier. So we refer this as an outlier. So then we or now try to see how we can get rid of it. So then the next one, we try to do some kind of also cognitive features visualization, where we also have all the data, all the 17 selected features. We visualize them and we add them some weights. So the next one is we are trying to also now do some also data exploratory analysis through trying to ask how many number of how often these involuntary features are applied during deceptive testimony in real-life court trials. So the frequency of applying open mouth, because open mouth is one of the involuntary cognitive index, which it is also oftenly used by some suspect or people under interview. So we also try to do this analysis so that we can see how frequent this features is used by the interviewees. So the first one, which is indicated as labeled as 1, shows that this feature is appeared several times on this 121 videos. So then the 0 is indicating that this feature has a less significant appearance on this 121 videos. So it shows that during deception testimony, majority of the persons in the video clips actually utilize open mouth features, so to deceive the judges and deceive the police. So then the next one is also, we also apply the same strategy on the deceptive testimony. So then as well, we try to find out the features that are less significant. They are not appearing so much and the people are not utilizing it in these clips. So we found that lab features is not that much significant. It's not applicable by most of the people in the videos during the court sessions and the police investigations. So then we proceed to this analysis to the truthful testimony in real life court trials, where we have just 2 classes. We have the level 1 and level 0 as well. So then in this aspect, we have the raise features, which is the rising of the eyes by the interviewee. So this shows that this feature is frequently used by almost all of majority of the people in the videos. So that is why it is having tallest plot. So then while the 0 is indicating that this is not well utilized by others. So then we also apply this to see that which features are less significant. So we use this, it is found that down hands features are less significant during truth telling in the court trial session and police investigation. So this is why we have the least bar plot of incognitive cues during lying. So then we do some further exploratory analysis, where we try to find out the percentage of involuntary cues per each 120 video clips in the truthful class. So we can see the plot and we see how this result is showing. So the next one is we are going to have also as well for the deception class, where we have the percentage of involuntary cues by each 121 video clips. Then the next one is we are going to have some also another analysis, which is try to give the approximate number of each of both the 2 classes, the deception classes and the truthful class, and how much features are utilized by each class. So in this, we have approximately 50.413223, and then percent for deception, and then we have 49.58677 for the truthful cognitive indices. So this is obtained according to the 17 involuntary cues, so which the code is presented here. So this is the code we use for this analysis. And then as well, we do also some further exploratory analysis, where we try to find out is one single feature to see how significant a single feature it is, based according to the class level. So we use, in this case, we use the smile feature, where we have the 0, it means as a deception, then 1 as truth telling. So therefore, we have the the smile features appears around 106 times in most of the video clips, while it appears just only during the truth telling, just only 15 times. So after this exploratory analysis, we try to do some multivariate analysis using principal component analysis. So in this analysis, we base this analysis using a singular value decomposition to analyze the feature space projection and its correlation. So the analysis to this group of involuntary features, we do some kind of strategy where we select some few clusters according to the temporal distance and the occurrence frequency. After that, we also perform some clustering using the same this PCA. So in the PCA, we do this scatter plot to obtain the two non-correlated features by the PCA axis, which maximizes the features and represented the variance in two-dimensional space. So because we don't have too much time to explain everything, in a nutshell, we have a Hotelin T, which we get a confidence score of 95%. So in conclusion, this analysis try to use the exploratory involuntary cognitive cube analysis to learn the relationship among the features, as well as to recommend the most significant features for effective lie recognition. In this study as well, we also try to analyze the evolution of features, though this is not carried out in this research, but actually in the future, we are going to use the locally estimated weighted scatter plot smoothing. So it's one kind of a comprehensive regression technique which try to give a trend in the captured features. So we will also try to show the trend line, the feature point, and confidence interval for each of the feature and its precedence value or for data points. So the trend also will try to give some lines which will schematize the evolution over time precisely and more smoothly than the existing box plot we utilized. So thank you so much for your listening.